Okay, so the next presentation is actually going to be split in two different parts. So first I'd like to introduce Michael Beesley, who is the Chief Technical Officer of Juniper's Platform Systems Division. And I'll let Michael explain a little bit more about that, but you have such a large group of responsibility within Juniper on the networking platform. So anyway, we're pleased to have Michael with us. So you're going to present kind of Juniper's view on OpenFlow and SDN, and then we're going to shift over to Jim Harding, who's going to talk to this from really a user's and implementation point of view. Okay.
Good morning. Thank you. Good morning. It's good to see everyone. It's a very well-attended conference. This morning, as I was kind of thinking about my thoughts and one of the key messages that I wanted to communicate, I got to the fundamental question of whether from an equipment vendor point of view, like Juniper, whether we see SDN as the end of networking as we know it, or rather the beginning of a new phase. Certainly there's a lot of things changing in the environment, in the overall IT ecosystem, being driven by many different forces. Certainly there's the consumerization impact of IT, the bring your own device aspect of modern networks, and there's the trend of virtualizing resources, both compute, storage, and ultimately the network itself. Our view is really that what is underpinning this is the network itself. It actually is the glue that really makes all of this work together and be able to provide these innovations and provide a platform on top of which these changes can occur. And as a consequence, we think that this is a great opportunity for ourselves as equipment vendors to add value to the equipment and to be able to play at a solutions level going forward. Really, what's underpinning that is two basic trends. The scope of the network itself is ever increasing, covering data center, LAN, mobility and Wi-Fi, as well as the WAN. And the second big trend is really the requirement for dynamic workloads, where compute, storage, and network is viewed as a resource pool that is elastic, that is easily provisioned, that is automated, and probably most important, cheap to run. Certainly in the customers that I talk with, CapEx is continually a concern, but really the focus going forward is on operational cost, on application agility, service agility, and actually ways to monetize the network itself. As we look at the situation, we do realize that what is needed most of all is a good programmatic interface between the application layers and the network layers. Today, we really don't have the mechanisms and the protocols to pass useful information at the right levels of abstractions from the application side into the network, and then from the network side back up to the application. And I think going forward, SDN has the promise and offers technologies and approaches that can really close that application to network divide. With regard to really being able to program the network and applying the knowledge that is there, it really breaks down into understanding several key things. Certainly, the physical world has an impact. Distance matters, speed of light matters, locality and affinity actually matter. And really, to orchestrate and program and provision a network efficiently, we really have to understand that aspect. The second thing that is vital to understand and to be able to facilitate is the information with regard to topology and path through the network, whether that reflects assurance levels, security policies, congestion, and so forth. And the third part, which I think is one of the if I look forward to how SDN technologies can really improve the state of the ecosystem, the third piece is critical, which is actually allowing applications to indicate to the network what they want to do and what the actual intent is. Today, networks are we've developed a lot of technology that kind of probes and as a kind of a look-aside mechanism is trying to figure out what an application is actually attempting to do. I think the world is more ideal if we have programmatic interfaces at the right level of abstractions that allows an application to actually indicate ahead of time to the network what it would like to do, what the application is going to do. And then also have an ability to have information reflected back off of the network to give indication to the applications on whether that would be successful or whether that's the most cost-effective thing. Certainly, as we build out sets of bidirectional APIs and protocols, it's worth really keeping in mind that we want to enable that high rate of change at the edge of the network to allow the virtualized resources to be provisioned and to be used in a very effective, very timely manner. At the same time, on the transport side, we really want to be able to publish topology and instrumentation and be able to actually program the topology and the path through the network. When we think about network programmability at Juniper, we do realize that it has to occur at multiple layers. I would say so far in the industry in general, we've maybe focused at a lower layer, really focusing at the box level and the element API level. I think going forward, the focus really needs to be around workflow, so that we can provide the programmability on a per workflow basis and create the right layers of abstraction to allow the useful information to be passed back and forth through the layers. Certainly over the decades that we've been building equipment and solutions, we've come up with a number of tools in the toolbox so far to be able to provision and program networks. They're very useful tools. They've got us to where we are today. I think going forward, what we would be most interested in the area of SDN is getting to a point where we have tools and protocols that can really facilitate both a high rate of change as well as high levels of abstraction to really facilitate the automation and the provisioning of network and network resources. When we think about abstracting the network and facilitating programming at the edge, it's really all about which resources are attached, who is allowed to speak to whom, and abstracting the connectivity details away from the resource orchestration. Really, SDN and OpenFlow in particular allows us to move from a more static provisioning model to more timely and dynamic. On the transport side, it's really about abstracting topology and being able to manage the path of communications and actually dealing with the physical realities that always ultimately come to play. As we communicate, whether it be applications or machines or people, ultimately the physical world does actually come to play. And I think there it's really about abstracting the path details away from the connectivity layer and moving forward from a more static configuration world that we have up until now to a software-driven world using technologies such as BGPTE and stateful PCE to really facilitate. So with regard to how we get there going forward, I think there's really two tracks to it. The first is architecting and building systems that are more powerful and address the fundamental needs of the actual network itself. We heard earlier that a fabric connectivity is extremely valuable, and certainly products like QFabric, they offer that. They offer a flat, universal bandwidth, universal connectivity solution with a single point of management. So the higher level orchestration and systems, the controller systems, don't have to scale out to an extreme level with regard to actually managing equipment. And I think certainly we believe at Juniper that this is a way we can really bring technology to bear, and we can bring products to market that really play in a software-driven network where the actual aspects and the attributes of the products themselves add extreme value, add significant value in and upon themselves, regardless of the abstractions and the orchestration systems that might be used on top of the system. I think the second track is to really facilitate as an industry, and you know, Juniper has a significant involvement with regard to the equipment side, but also on the software side. I think the second track is to really pursue a single point of programming such that a controller is able to orchestrate, provision, manage, and monitor a broad set of the actual equipment underneath that are used to put together a full solution. That would cover everything from WAN gateways to L4 through L7 services and security, Ethernet fabrics, whether they be, you know, converged or not, and really providing that controller platform, facilitating the lower operational cost of managing that network and that kit, but also facilitating very rich and well abstracted northbound APIs that allow significant functionality to be put on top of the controller in an easier, quicker manner, such that the abilities of the underlying network and the equipment in the network can be more readily harnessed and used. Certainly, from our perspective, we really feel that to get the full value out of software-defined networking and the technologies therein, as an industry, we should, you know, move forward and work together on really bidirectional communications to allow the application layer to signal more completely to the network, as well as the network to signal back to the application layer with regard to what is available and what is the status of the network.